So yesterday, I'm on the wrong page.
God is good. Actually, it's not.
God is good.
Actually, got that one wrong. That's why I went crazy on shell shockers. That's what made Allison good.
Shell shockers might be the source of the problem. Because you guys were playing that instead of reading.
Just yap the entire time.
Alright, so yesterday we talked about sequences. What's the pattern on this one? Plus 2. So to write the sequence, we put like t sub n. We backed up one term. So if you're adding 2, it's 1 plus 2 times n. So if n changes, n starts as 1, you're adding 2. When n is 2, you're adding 4. When n is, you're adding 2 2s. When n is 3, you're adding 3 2s. So it just keeps going like that. Today we're doing kind of the same thing, but we're learning to write it different. These are called recursive functions, and you could write the same thing. Well, one of the differences on recursive function is you have to define what the first term is. So t sub 1 is 3. So you have to start with that, and then you go over to the definition. T sub n equals, okay, what they all have in common is they use the previous term. So if you're trying to figure out the third term, this is t sub 3, then this term right here would be 3 minus 1, so it'd be like t sub 2. So this one, because they just add 2, in some ways it's easier, probably all ways it's easier. If you just add 2 as the pattern, you just put a plus 2 on it. Okay, so if you want like the fifth term, that means you're going to use the fourth term and add 2, right? Or if you want the sixth term, you're going to use the fifth term plus 2. Does that make sense? So t sub 2, for example, would equal t sub 2 minus 1, which is t sub 1, plus 2. T sub 3 would equal t sub 2 plus 2. T sub 4 would equal t sub 3 plus 2. You guys get it?
Yeah. Mr. Frederick is distracted. He's eating a chicken donut.
There must be junk in there that I didn't know about.
You should go check.
No.
Okay, sorry. But Leo has this bag.
With some carrot cake. Yeah.
Keep bagging with
Remember?
I thought he was bringing me to Mr. Cloud's
Oh,
house.
I forgot to zoom out.
She literally put you
I thought you were going to give it to Mary. He had to know that those weren't real.
I don't think he did. Maybe when it comes to phones, all of them are delusional. He didn't think we all put our calculators. Bro, that was so funny.
We're all the same.
He said, why do you guys all have the same case? And we're like,
We like to match.
Naughty. Alright. Number 1, let's jump in here. All we have to do is find the third, fourth, and fifth terms. Why did they skip to second? I don't know. Oh boy. So it says t sub 1 equals 6. Well, we can kind of cheat here. So, I probably shouldn't on the first one, maybe on the next one. T sub 1 equals 6, t sub n equals t sub n minus 1 plus 4. So basically, all the new terms are going to be the old previous term plus 4. Got it? So the first term is 6. The next term is going to be 6 plus 4. Yeah. And then 10 plus 4. And so on. They actually asked for the third, fourth, and fifth terms, so those are the answer. Does this make sense?
Yes.
Are you lying? You always say yes.
I'm so confused right
Okay,
now.
here we go. So, the first term they just tell us is 6. Got
Okay.
it? So, if we're looking for the second term, that would be called t sub 2. When n is 2, that means you're looking for the second term. Okay, to find it, you would use t sub 2 minus 1. So, in other words, you would use the first term plus 4.
Okay.
So that's how we got to 10. So the first term, remember, was 6. So this is basically 6 plus 4.
Okay.
Okay. The summation is that this always stands for the term that came right before it. Okay, this is the term we're looking for. This is the term that came right before it.
Alright. No, I got it this time.
Okay, and then you just keep adding 4. So plus 4 plus 4 plus 4.
Okay.
Okay, so 10 is the previous term plus 4. 14 is the previous term plus 4. 18 is the previous term plus 4.
Yeah, I got you.
Okay. Alright, it's really not, there's not that much. It's different than yesterday, but there's not a lot.
I'll understand it. Like, next time.
As per usual. I don't know if I want to write all this down, but
I should write out these 3 questions. 94, 98, for that.
yeah, you got the ones you did right. You just didn't do all of those. You got the ones you studied right. Okay, so we're starting. Wait, did I write this right? Oh, there's a minus 1 over here. Okay, so this time it's going to be times 3 and minus 1. That's the pattern. So the first term is a 1, because they told us. The second term, t sub 2, is going to be t sub 1, which is 1, times 3, 3 minus 1. Thus. Plug this in, we get 3 times 2 is 6, minus 1 is 5. Plug that in, 3 times 5 is 15, minus 1. 14 times 3 is 42, minus 1. And they won. These last 3 are the ones they wanted. Oh, I think I get it. Why? Yeah. I realize why they didn't ask for the second term. Because in some of these problems, they give it to you. Alright, so first term is 1, so the second term is 1. Okay, maybe I should write this one down. So we're on the second term, so n is 2. So we're going to take the first term plus 2 times n, which in this case is 2, and then we're going to subtract 1. The first term is 1. So it's 1 plus 4 minus 1. Okay, so n is changing. So we're on the third term now, so we need the second term, 4, plus 2 times 3, because we're on the third term, minus 1. So 4 plus 2 times 3, 6 plus 4 is 10, minus 1. And then now we're on the fourth term, so we're going to take the third term, 9, plus 2 times 4, 8, 17, minus 1. Does this look familiar? We had this yesterday. It was not written recursively. The fifth term is 16 plus 2 times 5 is 26, minus 1, 25. These are just the square numbers. I might have hurt Paxton's feelings yesterday.
What'd you say?
He was singing at me in class. I was like, and then he would lay his head down. But he does that normally, so I don't know. T sub 1 equals 2. Warm in here. Okay. So this one, the new term is dependent on the past two terms. So we already know 1 and 2 is 2 and 4. That gives us the first two terms. So the third term equals n minus 1 would be the second term. 3 minus 1. So it'd be 4 plus 2. So you just add the previous two terms on this one. Does that make sense? So if we're on the third term, this is the 3 minus 1. This is the second term. This is 3 minus 2. This is the first term. Okay, anyway, t sub 3 is 6. So basically the pattern is we're just adding the previous two terms to get the new term. So the fourth term is going to be the third term plus the second term. And the fifth term is going to be the fourth plus the third. T sub n equals t sub minus 1 minus t sub minus 2. Where did they put parentheses? Did I miss something there? Oh, squared. Okay. So the first two terms they give us are 5 and 8. So which one are we going to use right here? We're going to use the 5 or the 8? The 8. Because this is the 3 minus 1. This is the second term. Because we're on the third term right now. So 3 minus 1 gives us the second term. The second term is 8. So this is 8 minus 5. I guess if we're squaring it doesn't really matter, but 8 minus 5 is 3, 3 squared is 9. And then we're going to do 9 minus 8 is 1, 1 squared is. And then 1 minus 9 is negative 8 squared. So this one's kind of all over the map. Definitely not an arithmetic or geometric sequence. Okay, so on number 11, they want us to redo number 1 like we did yesterday, which they call it the explicit definition, which just means writing it like we did yesterday. Not using a previous term, just using like adding and multiplying. Okay, number 1 was 6, 10, 14. Okay. So these were some of the numbers on number 1. So remember how we did it yesterday? The pattern is +4, so we backed up 4. So it starts with 2, but when we want to keep adding 4 over and over, we put an N right there, because that tells you how many times we need to add the 4 to get to the next term. I think I mentioned this yesterday, but if you wanted to multiply 4 over and over, the N should be in the exponent, because that's what makes you multiply repeatedly. Hopefully you guys got that. Anyways, 13. Okay, same thing. We're getting recursive definitions. 9, 13, 17, 21. Oh, I guess we're going the other way. Okay, so with recursive, you always define the first term, at least the first term, sometimes the first 2 terms. T sub 1 is 9. T sub n equals the previous term, T sub n minus 1. And then what? What is the pattern here? How are we getting from 9 to 13 to 17 to 21? Plus 4. So it's kind of like number 1, basically. Pretty much. One, 3, 7, 15. Uh-oh, we might have to use our brains. 15. All right. What is the pattern?
Would be 2 and you add 1.
Yeah. Yeah, there's a couple things going on. It's times 2 plus 1. I don't know. Is there an easy way? I think you just kind of have to play around with it and see what works. I don't think there is an easy way to like just know. Let's see. Well, okay. Actually, we can do that. Okay. So the first term is 1. Okay, so we need to add 2, then 4, then 8. So what do all those numbers have in common? How do you add 2, then 4? Sorry, Brandon, the way you were thinking of it was more like yesterday's. But yeah, we gotta write it recursively. How do we add 2, then 4, then 8? You guys know what these numbers are? It's not going up by 2. What's happening? They're powers of 2, right? So how do I write powers of 2? Like 2 to the first is 2, 2 to the second is 4, 2 to the third is 8. So this is how we get powers of 2. 2 to the n. So actually this is a little bit wrong. Let's plug in and see what happens. So if I plug in 2 for n, I get 2 minus 1 the first term plus 2 to the what power? Or on n is 2, the second term, so this would be 2. Now, the first term is 1. Do I want to add 4 to 1? No, I only want to add 2 to 1. So this is a little bit too big. So how am I gonna fix it? Take a 1 off right there. On the second term, we will only want to be adding 2, not 4 yet. So if we just back it up 1 step by putting a -1 there, then we'll be adding, instead of 2, we'll be at 2 to the second, we'll be adding 2 to the first. Which will give us that +2, which would give us the 3. And then when I go into my third term, I want to be adding 4. So 3 minus 1, that'll be a 2. 2 squared is 4. A little bit of a brain teaser. Okay, 1, 3, 16, 15, 21. I should probably look at the evens, see if there's any landmines. Okay, what's the pattern here? Maybe a little bit easier. Going up by 2, 3, 4, 5, 6. So, first term is 1. Okay, so how do we get to the next term? Alright, to get to the second term, we want to be adding 2. To get to the third term, we want to be adding 3. To get to the fourth term.
So you put it in the extra or?
No. So basically, the second term we want to be adding 2. To get the third term we want to be adding 3. To get the fourth term we want to be adding 4. So to get the nth term we want to be adding n. So in other words, we need to add n. Because n is increasing on each term. So for example, if I'm trying to get the second term, t sub 2, that would equal t sub 2 minus 1, the first term, plus 2. And the third term would be the second term plus 3. And so on. Hmm. 15 might have been the hardest. No, I'm looking at the evens right now.
Can we stop there?
No.
What about 18?
Let's see. It looks like it's times 2 times 3 times 4 times 5. So you'll need to multiply by, the second term is times 2, the third term is times 3. So instead of adding in, you're going to need to multiply times in, yeah. All right, 19, give the first 8 terms of the sequence defined by the recursively by t sub 1 is 3, t sub 2. Okay, good. Starts kind of normal. Let me write this down real quick. T sub n equals okay, I know it says, oh, it says give the first 8. Okay, never mind. So we're starting with 3 and 5. Those were given to us. Okay, so when I'm going for the third term, t sub 3, I'm going to do t sub 3 minus 1, which is the second, t sub 2, which is this one, minus t sub 3 minus 2, which is t sub 1, the first term. So it's this one minus that one. So 5 minus 3 is 2. And that pattern continues. 2 minus 5 -3 minus 2. My commas are getting bigger and uglier. -5 minus -3. You gotta be careful on these. You get off pretty easy. -2 minus -5. How many did 2, 3, 4? 3 minus -2. Okay, you guys see what's happening here? This next term is going to be dependent on, it's like that minus that, which we've already done that at the beginning. So this is going to start repeating itself. Okay, this is the answer to A, by the way. The B question, observing the pattern you get in part A, tell what the 1000th term of the sequence will be. All right, well, how far does the sequence get before it starts repeating itself? 6. Okay, that means that the 7th term would be like 3, the 8th term would be 5, the 9th term. Okay, and then the 12th term, because it would be this, and then the 13th term, it just starts over 14, 15, 16. So how are we going to find 1,000? Well, if we divide 1,000 by 6, and the calculator might not help too much here because, well, maybe a little bit.
166.
Because we need the remainder. The remainder tells us how far are we into our next sequence, into our next pattern. So how many times does this go through 6 numbers? And then we need the remainder to tell us where we are in our little chain of events here. So 6 goes into 10 once, 1 times 6. When's the last time you guys did this? 6 goes into 40 6 times. I guess you could, well, okay, 6 goes into 40 6 times. And then probably in 5th grade, we put like remainder 4. You guys remember doing that? Which means if you divide 1,000 by 6, we'll have gone through this loop 166 times. And then the remainder tells us plus 4 into the next one. So we would end up at -3.